All right, so welcome back to part 4.4, part two. So now, again, we're still looking at related rates. So, right triangle, example four, a right triangle has sides whose lengths are changing. The short side is increasing at a rate at 3 inches per second, and the long side is decreasing at 5 inches per second squared. So, again, this is a right triangle, so we got to make sure that we're making a drawing for a right triangle, right? And then again, they're saying the short side and the long side. They're not saying the hypotenuse, so be careful, right? So here we got 30, and then down here we have 40. And then it says find the rate of change of the area of the triangle at the moment. The short side is 30 inches and the long side is 40 inches. So again, given in this case, the short side, let's call it a ds over dt, is changing at a rate of 3 inches per second. And then the long side, so we'll call it dl over dt. Again, with respect to time, because if you guys notice, is inches and seconds right there. This one is changing at a decreasing rate of 5 inches per second. So that would be minus 5 inches per second. And then from there, we want to find pretty much again, it says we want to find the rate of change of the area. So we're looking for dA over dt. And the equation we use to find dA over dt is the equation of the area of a triangle, which is the area is equal to 1/2 base times height. And here we're looking at, again, 1/2 is a constant, so just leave it outside. So you're going to have to be using the product rule. So let's change color. So we have B and H, right? In this case, we're not using B and H. That's right. We're actually using length, the short and the long side, right? So I'm going to use, I'm going to substitute this for L. I'm sorry, the long side will be L, and then the short side will be S, the height. So here again, it would be L and then S, and then here dl over dt. So I want to make sure that I'm using the same variables as I did right there. And then that's ds over dt. Again, draw your fish, and we end up with dA over dt equals 1/2, which is a constant, right? Still remains. And that's going to be L times ds over dt, and then plus S, the short side, times the rate of change of the long side. And then from there, again, we're going to pretty much substitute. So let me get rid of this right here. And then, so we say this is equal to 1/2. And then L, which is at this moment happens to be 40. And then times ds dt, which is positive 3. And then plus 30 times dl dt, which is negative 5. Again, simplify that, you get 1/2 times 120 minus 150. You get half of negative 30. So that would be negative 15. So we can say that the area is changing. Area is changing at a rate of, or actually decreasing rate. Again, even I myself keep forgetting. So make sure you guys remember to say at a decreasing rate. Decreasing. All right. And then from there, so decreasing rate and of 15 square inches per second. All right. So here again, we found the rate of change for uh, the area of the triangle. So now we want to know how fast the hypotenuse is changing at the moment. The short side is 30 inches and the long side is 40 inches. So again, we're still using the same picture, right? We're still going to say this is our right triangle. Again, let's make this the short side, 30. This is 40. And we want to know how fast the hypotenuse is changing. So we're given, again, same thing, right? We're given dl over dt, which was negative 5, right? inches per second. And then we're given ds, right, the short side, how fast it's changing, at 3 inches per second as well. All right. And then we want to find the hypotenuse. So in order for us to find the hypotenuse, again, you're going to be using just your Pythagorean theorem, right? So we're looking for the h dt, right? H for hypotenuse. And then the equation we're going to use is going to be L squared plus S squared equals H squared. All right. Again, it's the same, right? I just changed the variables. Don't freak out. So from here, you're going to take the derivative. So that's going to be 2L times dl dt, right? Equals, I'm sorry, plus at 2s times ds dt, right? Don't forget to attach that derivative part, equals 2h times dh dt. And this is pretty much what we're trying to find right now, right? dh dt. So here, what we want to do is substitute the things we know. We can figure out what the hypotenuse is. Now, if you guys haven't figured it out already, this is the classic 3, 4, 5 triangle. So the hypotenuse is actually just 50, right? 3 squared plus 4 squared equals 5 squared, or in this case, 30 squared plus 40 squared equals 50 squared. So it's kind of the same thing. So here, again, we're gonna do the substitution. So I'm gonna change it up. I'm gonna do it up here now. So dh dt, here it's 2L, so that's gonna be 2. Well, if I solve for that, I'm just gonna divide everything by 2h, right? Right there. And then here, so it's gonna be 2L, so that's 2 times the long side, which is 40. And then dl dt, which is -5. And then plus 2 times the short side, which in this case is 30. And then times the rate of change for that, which is 3. And then everything divided by 2 times the hypotenuse, or 2 times 50, right? And that's equals 2. Again, start simplifying, right? So this is 2 times 4 is 8. So that's negative 400. Plus, and then we have, so 91,880. And then over 100. So that's going to be negative 220 over 100. And then here, we can pretty much say that the hypotenuse is changing at a rate of negative 22 over 10 inches per second, which is 2.2. All right, so